I was lucky enough to be in the United States when some of the formative research in this area was unfolding. And one of the things that I was part of the discovery of with Martin Ralph and Mike Menneker is the nature of the master clock within the brain. There's a structure deep within the brain, within the hypothalamus, and it sits above where the optic nerves go into the brain and fuse. And it's a structure called the suprachiasmatic nuclei, mercifully abbreviated to SCN. And that seems to be the master clock within the body. Then it was discovered that individual clock cells within the structure, and there are around about 50,000 in each SCN, in humans, that you could take one of those cells out and it would show a 24-hour oscillation in isolation, which told you that the clock isn't the product of cell-cell interaction, which is what we originally thought. We thought it was an emergent property of a circuit, but rather a subcellular molecular mechanism. And of course, the Nobel Prize in 2017 was given to Young, Rosbash, and Hall for their characterization of the molecular clock, not in humans, not in mice, but in flies, in fruit flies. And what turned out to be the case is that you've got a bunch of clock genes which are turned on. They make proteins. Those proteins form a complex. They go into the nucleus and they turn their genes off. Those proteins are then degraded, and so the genes can start to make message and then proteins again. So what you have is a cycle of protein generation and then degradation, and that's at the heart of the clock. So you've got about 100,000 in total, 50,000 in each SCN, working together to generate a coordinated circadian output. And what we originally thought is that, well, this clock is simply imposing, forcing 24-hour rhythms on the gut, the liver, you name it. And then it was discovered that every cell in the body has the capacity to generate a circadian rhythm. So what's happening is that the master clock in the brain is coordinating the rhythmic circadian activity of billions and billions of individual cellular oscillators organized throughout the various tissues and organs of the body. So we use the shorthand of a body clock, but actually what we've got is this extraordinary sort of time structure, this circadian system that is fine-tuning and regulating everything we do. Okay, it's great. You've got that internal timer. But it's of absolutely no use. It's no adaptive value unless the internal day is locked on to the external world. And of course, our classic mismatch would be jet lag. You know, when we fly across multiple time zones, our body time thinks you are still back in Glasgow, but in fact, you've moved forward or back in time to either the United States or Australia. And so it takes us a while for our internal circadian systems to adapt to the new time zone. And how do we do that? Well, it's primarily, but not exclusively, exposure to the light dark cycle. That's what's so important in setting the internal clock to the external world. Now, we can help it by eating at the local times and maybe doing exercise at local times. But it's primarily light that is the entrainment cue for making sure that everything is beautifully aligned with the external world.